And welcome to the Bridge Show, live from Oslo, Norway. And we are going abroad today, so follow the show. It is Tuesday and we are back in the Bridge Show from the Oslo studios of Bridge Technologies in our basement, in our full-blown IP studio. We are broadcasting directly to you. And today we have a treat, one of the masters of the intensive task of navigating the ST2110 and of course, not to forget, the new IPMX standard with AV over IP. I bring you Jean Lapierre from MATROX. Welcome, Jean.
Hi, thanks for having me.
Oh, it's a pure pleasure, Jean. It's been so long. I think we met during one of the JTNM and Ames-based interops. I think it's 5 years ago now.
You're probably right. Yes, it's been an interesting road.
No kidding. And I remember that, you know, we were struggling to set up interoperability and anything. And you know, have come a long way, that's for sure. And I believe the last time we met physical was in Wuppertal at the wonderful interop at the Riedels campus in Germany.
Yes, wonderful Germany. Very nice. Very nice place to be. I seem to remember nice conversation, having a few beers.
That is very true. I remember it was a couple of beers, probably only one and two. And of course, we ate some amazing Wiener Schnitzel.
Yes, very, very good. Yes.
But we're not going to dwell too much about food, even though, you know, it's food for thought at least. The key thing here is that we're going to talk, of course, about MATROX's engagement into the 2110, because you guys manufacture one of the most successful and mostly used IP-based interface cards on the planet, don't you?
Well, I like to think it is, yes. We worked very hard to develop that product. You know, we started with the 2022-6 and we went to those first interrupts, and it was cool for our customers because we mostly sell these cars to OEMs that develop their own products. And so for us to go to interrupts, we would go there and make sure that our card was working well with everybody else equipment type thing, which was good for our customers because then they knew their product was going to interrupt very well with other people's product type thing. So that was the idea behind those interrupts. Then it turns into 2110 and Ames got involved promoting 2110, and then we would go to those, as you described. This is where I met some of your wonderful engineers and discovered your VB440 product that I really liked. At the time, was very impressed. And yeah, we would sit there and do some testing for about a week, and then scratch our head and say, oh, we have to do a good demo for the Ames showcase at NEB or at ABC. Work very closely with you guys and other people in the industry, which was very good, very interesting to be able to you know, work with other companies you don't usually work with. You usually meet them more on a competitive level, but now we were like all together trying to get these things to work properly.
Exactly.
And to demonstrate that it was ready, and yeah, it was cool stuff.
It definitely is ready. We, you know, have a couple of your cards that we use intensively in our lab for a lot of the reference streams. So absolutely, we're that's ready.
Yeah, and I use your VB440 in my labs to check that we didn't screw up when we do the release of software, which is always very useful. And
it is.
Yeah, it was very intensive work, hard work at times when things don't work, but was also very interesting to brainstorm on what cool demo we could do. I remember one year we all worked together. We did this demo where we had like UHD and 1080p and standard definition and both in 60 hertz and 59.9 and 50. All of that on one screen, explaining to people, all that is being transported over IP. Like it doesn't care about the resolution or anything. It's cool.
It's very true, and I'm glad you mentioned it, because it's still today mixing resolutions on the same kind of display system is not really common. It's considered pretty advanced, and we were doing it back in the day, that's for sure.
Back in the day, I started at MATROX right out of university, which was a little while ago, as you can see. And I started with analog component, then composite signals, and then we went to digital, SDI, HDMI, things like this. And now it's all over AV over IP, and we're saying back in the days already.
That is very true. Well, it's maybe an exaggeration, but we are going to go a little forward, because as I try to say, people that ST2110 is not the future. It's already here. It's been here for many years now, and it's a technology that is already taking over because of obvious reasons. It's fast, it's nice, blah, blah, blah. But it has also a lot of different purposes. And one of the purposes that I would like you to talk a little more about was Ames's last initiative in actually bringing some of those very fanciful technologies more into the audiovisual AV kind of sphere with the IPMX. Tell me a little about MATROX and IPMX.
Yeah, sure. Once we got done with all those nice interrupts and 2110, and things really started going very well, and like people are deploying 2110 in their facilities and everything, then MATROX is we have many divisions at MATROX, and we have lots of equipment outside of the broadcast space. Like we do a lot of Pro AV. We also do some imaging stuff that's used in medical, and it's used also on production line for testing chip and things like this. So, and we have a big division that works on Pro AV, and Pro AV equipment is basically, I would say, AV wherever it's not broadcast, which is a simple way of putting that type thing. So digital signage, you see that at airports with the screens, and the screen at the fast food store behind the, now instead of having physical sign, they have screens, and they show you menus.
All electronic.
Food. So that's all like Pro AV. Universities, teaching in university, recording all these video feeds, broadcasting them on the web so student can watch from outside classroom. That's all Pro AV space. Yeah. And so Ames was looking at we suggested to Ames that, ST2110, which is a standard, would be really cool if we could use that in a Pro AV space. Pro AV space is dominated by proprietary standards.
Yes, and many of them. There's a ton of different types of standards.
Exactly, and they're all standards. They're like company X will develop a technology, and then they sell their product with that technology, and if you don't buy product from that company, or if you have a switcher from that company, you can't connect it to another piece of equipment from another company, because they don't have interoperable standards, right? No. And ST2110 is very interoperable standard. So we said, hey, why don't we use ST2110 in a Pro AV space?
Smart move.
And the match is very, very good. Except, when you look at it, you realize that, there's some stuff in the Pro AV space that we don't find in broadcast, like on a HDMI signal, for example, your Blu-ray player, it puts content encrypted so people can copy it even while it's on the wire. And that's called HDCP, and that's not really something that 2110 was covering, because we were in broadcast. We don't use these kinds of technology. There's little details here and there that needed to be addressed, And
It's like, you know, RGB signals. That's not really covered in traditional types of broadcast.
Not in traditional, although it is in the ST21 official spec.
Yep.
So it's there. It's officially there, but really nobody is really using it because there's not a real need in broadcast for it. Although I have some customers that do a lot of CG work, and in CG work, the RGB becomes more relevant. But anyway, so we're looking at all of this for IPMX, and we're working on adding, if you want, some pieces of standards that say, okay, in IPMX, we'll also have a way of leveraging. You know, we talk a lot about ST2110, but there's also another technology that was developed along the line of all this work we were doing from AMWA, the NMOS, the suites of standard, which is very, very important in IP and plays a role for IPMX as well. So we're looking at what's been created for broadcast, and we're saying, okay, so if we extend NMOS to do this, we can use it for this or that the Pro AV space needs.
Exactly.
And then, so that's the work we started, and VSF got involved. I'm actually the chair of one of the VSF working group for IPMX. And in that group, we're trying to make, we are writing, one of the spec we're writing is about the timing. We're simplifying a little bit the model for ST2110 is designed for broadcast studio. In broadcast, everything is gen-locked. And in Pro AV, almost nothing is gen-locked. I mean, your computer output doesn't have a gen-lock. So we had to cover what happened when there's no gen-lock, basically. So we're doing that in that spec. And then we're going to, you know, describe how to carry the HDCP stuff, like the copy protection and things like this. And so that's the work we're doing in VSF with respect to IPMX. Basically, adding to the standard based on ST2110 standard, so we can say, hey, here's a standard based on ST2110, tried and true. It's in use today. Today, Pro AV uses SDI when it suits their need, also, right? So it's not like there's this blurred line between broadcast and Pro AV.
Absolutely. Because, you know, you have concerts where you have then huge outside broadcast vehicles that is used for the main production, but there still is a huge AV component because of the back screens, a lot of projection systems, and a lot of additional technology that, again, professional broadcast may not address, especially when it comes to higher resolutions, because in Pro AV, you don't really need to constrict to broadcast resolutions. You can actually invent any kind of resolution you want to work with on your LED back screen, if you like. And that may not be supported by standard broadcast, but of course with IPMX, then you can actually invent your own kind of grid, if you like.
Yeah, that's a good point. In Pro AV, we have customers that do extremely wide screens, right? They'll do a picture that we call those video walls. So you put together many monitors, and then you end up with a monitor, like, I don't know, 8 monitors across one high. It's a very thin strip. You'll see those around stadium. Right? They'll have a video playing and it's moving around type thing. And it's like, for the system, it's one super wide screen. Right? And so, that kind of technology, we have to make sure that with our IPMX, we can cover this type of things. That's actually one of the things we're working hard on, is to be able to synchronize all those monitors.
Exactly.
It's tricky, and we have to make sure that our specification enables you to do that. We're adding little tricks in NMOS in order to help synchronize all those monitors. In broadcast, we don't really have that problem because everything is based on gen-lock, and so the SDI screen naturally are locked and everything. But in Pro AV, we use a lot of DisplayPort or HDMI, and it's tricky to synchronize all those monitors. Like
no kidding.
Of the device that drives the monitor to make sure they're all synchronized.
Well, it will be the day when you get, you know, LED panels for stacking that comes all together with a 10 or 25 gigabit with IPMX interface directly. Won't that be nice, Jean?
Yes. Also, I must admit, though, in Pro AV, one of the things that's we're working hard to make happen is there's a lot of existing network, and they work with Cat5 cable, and they're giggy, 1 gig, or even like 5 gig. And so we're working also to make sure that our standard has some very nice quality compression that fits on a gigi network. So the idea is to say, you don't have to build from scratch a very expensive 25 gig network with switches, with PTP and everything. You can actually use IPMX on a inexpensive pro level switch. I actually did some tests. I can use it on a $120 switch with no PTP, and it works fine. Like, it depends on your use case. So it's a broader range that we're trying to enable with IPMX.
Yeah, and of course we've seen right now it's the big battle of the compression standards. The of course compression standards based around more distribution forms, and then of course we have JPEG XS, which is now very popular for at least light compression schemes. What type of compression will you foresee that in a couple of years we'll find in IPMX?
Well, IPMX being based on the standards from SMPTE, basically -22, you can use any type of compression you want, type thing. One of the ones that's definitely going to find itself there right now is JPEG XS. But I think there'll be other compression scheme that will bring in as well. Talking about compression scheme and Pro AV, and how Pro AV ends up mixing up with broadcast. Funny you should mention these different compression technology. We see that blur line between Pro AV and broadcast is even to the point where broadcast is bringing in technology from the Pro AV space and using it. I've seen broadcasters a few years back would say, 2110 uncompressed, we need uncompressed, zero latency, everything. That's like, there's no way we'd use compression, to recent days now where I've seen broadcasters using H.264, 420, 8-bit, like talk about like not your typical broadcast 10-bit, right?
Well, it's right these days, with the extreme influx of what we call remote production, where people work from their homes, from distributed offices, centralized equipment, more centralized equipment architecture, and of course distributed production, where we have a lot of people on different venues. Then obviously people are trying out a lot of methods. And one thing, because MATROX, it's not only about compression. You have other products like traditional KVM architecture, but of course over IP.
Yeah, that's true. To do remote production, you think instantly of, we actually make products for that as well. That's how I got started in IP, by the way, with those encoders. A box, you feed in a video and out comes out a web stream type thing, and we would use that to help people, like in churches, broadcast on the web, like on Facebook and things like this. That's how I got started with IP. Before that, I was mostly doing traditional SDI, baseband, video editing, things of that nature. And then broadcasters started to look and approach us and say, hey, we would need something like this, but more higher quality. MATROX is a very crazy company. We actually develop our own H.264 chip, right? So we built our own chip for our own use in our company. And the advantage of that is we have a H.264 chip that can do 420 8-bit, of course, and we use it for these web streaming, but it actually does 422 10-bit, and actually does 444 10-bit as well. So it does a very wide range. So then we started to build products for remote production, what we were talking about, remote production like 4 or 5 years ago, where you have cameras they're connected to these encoders, and these encoders send a very high quality over a network back to the production, which is at the home base. Right?
Exactly.
And so they can send just the camera operator with these boxes, and then they still do the production at the main facility. And then it's fast. It's easier to cover many events in one day. That way, you don't have to bring a whole truck with a whole crew.
No.
And it's funny to say that's traditional way of thinking of remote production, but in recent times it's become remote production also means there's nobody at that main facility.
No, exactly.
Right, and all the equipment is there. It's the same equipment, and the people are actually at home, and they're needing to control all this equipment that's at the broadcast facility. And how do we do that? Right, and so Pro AV comes into the rescue here, because in Pro AV, KVM are pretty standard things, and traditional KVM, with high quality of being able to carry this screen picture that's 60 frames a second, that has an Excel spreadsheet with lots of detail, bringing that somewhere where the operator is, typically, let's say, control rooms, disaster recovery rooms, things like this. They don't put the computer in the same room with the people. They put it somewhere else.
Exactly.
And then they remote into them. And so we had been working on technology using our H.264 technology, where we can do these types of KVM, but use it over a 1 gigi network, like a regular gigi network. And actually it works over 100 megabit also, because it's very low bit rate, very high quality, but very importantly, very, very low latency.
Exactly.
Right? And so when we were approached by a broadcaster saying, hey, we need to know what you have in terms of KVM, because we want to do these things, but we're looking for KVM that we can use over the internet. Right, because our people are at home and they have a regular internet connection. It's not like we can run a dark fiber to their house and things like this. And we say, well, funny you should mention that. We developed this KVM technology based on this, and actually works very well over WAN. So you can, and then supports tunneling and VPN and all of that nice security things. And the Pro AV technology has been leveraged by these broadcasters to be able to work from home. Also, those little encoders for the web are being used to send the talent is at home too sometimes, right? And you don't always want to use these webcam to be feeding the talent back home. So you can actually use a proper camera with those encoders that were designed to be maybe at a stadium. Now they're in the home, and you just dial down the bit rate, and maybe you have to play a bit with the 422 versus 420, or the 10-bit versus 8-bit in order to get it through, instead of a dark fiber, being able to go through the internet. But it works out pretty well, and the latencies are, of course, from the get-go, were designed to be very low for these remote production type of equipment. So Pro AV broadcast, it's all a blur, and if we're successful with IPMX, it'll be even more a blur.
Yeah, but that's the whole point, giving people a lot of choice in the tool sets. The more tools you have, the better kind of building you can build, or at least that's Tim, the tool man, says. What do you say, Jean? The more, the merrier.
Actually, that's an excellent point. That's what using a standard brings, right? Because if you have something that's standard, then you can have many manufacturers making pieces of equipment that all work together. And so you can pick and choose. Oh, I need a screwdriver, and I need a hammer, and I need a Phillips screw and a Phillips screwdriver and things like this. And you can build everything you want and buy it from whoever has the best solution.
Absolutely.
The equipment you need.
And again, as you say, the interoperability is the key here, because again, that means that you are vendor agnostic, and that's good, that's protection. But also, again, that you can combine all these tools in a lot of ways that maybe even the vendors haven't actually thought about. and also that you then have one piece of infrastructure, that everything is IP. As long as you have an IP base with enough speed and low enough latency, you can just continue to build. You can just continue to add on signals for whatever use. I love it. I love it, Sean. This is exactly where we like to go.
Yeah, you're right too, that also if you have options with IP, you can have like a remote place where you have some equipment maybe that's based on Gigi network, because you're just you don't need more than that type thing, and then you have another place where you have higher bit rate with
exactly, and
then you can bring in all the stuff from the lower bit rate stuff into your central big hub, and then you have monitoring. You know, with the standard also come this concept of you know, we have this vision at MATROX that you know, you'll be able to monitor on your multi-viewer your KVM,
yep,
right? The video feed and the audio feed from your KVM. And then today that's like unthinkable. Like all the KVM, they all use these proprietary technology.
Yes.
And then now they're over IP, but they're proprietary. So if they're over IP, but they use a standard, then a piece of equipment that was never designed to interact with a KVM could be used by somebody that has a smart idea that goes, oh, I'm going to be able to monitor the KVM. And then, you know, if there's a problem, we'll be able to use maybe AI to analyze something from that screen, because the operator just operates normally, but the AI is helping in the back, right? So
there is an infinite way of you know, putting all these things together, and holy Moses. Sean, I know that you're very, very busy, and I thank you so much for spending some time with us, and I love to see you, man. It's been too long. Oh, I've been remembering those, you know, beautiful days in Wuppertal, and we'll be back, don't you think?
Yes, we will be back. And I remember mostly those beautiful nights in Wuppertal.
That's true. We were a huge team with discussions that lasted until, I believe, even the cows came home.
Yes. And some people's.
Sean, it's been a pure pleasure. I would then let you go back to your busy day. And again, thank you for joining. I can't wait to see you. I hope pretty soon. In the meantime, give all our best to all your colleagues and the great people at MATROX. And see you soon.
Thank you. Thanks for having me, and say hi to the team for me.
I will do so, Sean. And to the rest of you, I will bid you farewell from our IP-based studio here in the basement, talking about IP. Oh my goodness, yes we are. It's, you know, another day, another ST2110 production. We are going live from our broadcast center here in Oslo, Norway. And don't forget to tune in next Tuesday for another bridge show with, who's it gonna be? The mystery guests. So, welcome back to the show, and so long, and have a nice day.